Hey guys, welcome back. In this video we're going to use this data that we have here that we've been using on test scores for students. Basically what this is doing again is finding a correlation between English test scores and math test scores of several students. In this particular video we're going to go ahead and do a linear regression line, and we're going to end up calculating standard deviation and the covariance as well for all of this data. And in your IA, you're going to have to show all these calculations by hand. So you're going to have to put all these steps in your report. So this is kind of how I would do it if I were you. I recommend is just put this in tables. So first thing I want to find is the average or the mean for these test scores. So I'm going to call this my X test score and my Y test scores. So we're going to go ahead and say, okay, X bar, we're going to call it the average, and we're going to have Y bar as well. And here we're just going to say equals average of all the test scores. And that gave me that. And then we're going to have average for the other test scores, the math test scores. Better if I spell it right? Okay, average. Okay. We'll close that up, and there are the two averages. And now what we're going to do is we're going to take the X test scores and subtract the averages. We're going to have to do all of this. So I'm going to put that, let's put that right here. I'm going to call this X minus X bar. Okay, these are my test scores right here minus the average for that. So the first one, I'm just going to put equal sign. I'm going to select the first test score for English, and I'm going to just subtract this average right here, which is 62.8 for me. This will be different, of course, in your data, but this is how the procedure is done. And I'm going to take this, I'm going to hit enter actually, and then I'm going to take this, and I'm going to drag it all the way down the test score column. And it's going to give me the differences for all of them. We're going to do the same thing with the Y test scores. It's going to be Y minus Y bar. Okay, and then this one's going to equal the first Y test score, and we're going to subtract the Y average, which is right here, 67. Enter, select that, drag this all the way down, and there you go. And then we're going to go ahead and make another column here, or I actually want to multiply these two columns together. And we're going to use this for the covariance calculation. So we're going to have X minus X bar times Y minus Y bar. It's just my label right here, so I know what I'm looking at. And here we're going to say equals, and it's going to be this one times this one. And I'm going to go ahead and click and drag this all the way down. Okey-doke. And then we're going to do just a few more. On this one, what I want to do is take my X bar column and square it. So I'm going to have, this one's going to be called X minus X bar. Yeah, my X minus X bar column. And I want to square that. So my label is going to look something like this. Oops. And then I'm going to have one for the Y minus Y bar column, square every element in that. And this is so I know which one I'm looking at. I'm just giving labels here. This is going to equal this times itself. Just put it like that. And then I would drag down for this one. And then I will do this one. And this will be the Y bar times itself. So it's Y bar times itself again. Hit enter. And then copy all the way down again. Excel's so great that it'll just do all this all the way through. Okay. And now what we need to do from this point is to calculate your covariance and your standard deviations. So let's go ahead and open this up real fast. Let me kind of show you what I mean by that. Your covariance is also called frequently SXY, and this is given by the sum of your x minus your x bar, or your mean, we'll call it that, times your y minus your y bar. You've got your differences between your x observed values and your average, okay? And the same thing for the y. We're going to divide this by the total number of scores you're looking at. And then we have standard deviations as well. So we'll call them standard dev. And this is for both x and y. So the standard deviation for x, this will be given by the square root. And then we got a sigma. This is going to be your x minus your x bar, all your elements squared, and then we're going to divide this by the number of elements. And then we're going to have the standard deviation for the y test scores, which will be your math test scores in my particular data set. And this is going to be the sum of y minus y bar, elements that are all squared, divided by the number of elements you have. Okay, and the whole reason we're doing this is we're trying to get to a linear regression equation if we can use one, but we'll have to find the Pearson's product movement correlation coefficient first. But before we get to that, let's actually write down the Pearson's product movement correlation coefficient equation. It's going to be R, and this is going to equal your covariance divided by your standard deviation for x times your standard deviation for y. Okay? If R, the absolute value of R, I should say, if the absolute value of R is greater than 0.5, I don't know, I messed up there. If it's greater than 0.5, let's write it like this, then we can actually go ahead with the process of finding a linear regression equation. If that value is not, the absolute value of that R value is not greater than 0.5, it's really pointless because the correlation isn't strong enough to merit the creation of a linear regression equation. But if you actually get that far, and some of you should be able to make an equation for linear regression, and this is the formula for that. It's y minus y bar, and that's going to equal your covariance again over the square of the standard deviation for your x values times x minus x bar. This is kind of the end-all goal here if you can get this far. But again, this is absolutely necessary if you're doing any sort of correlation comparison. And if you can satisfy this condition, then you can go ahead and make a linear regression equation as a major math process. So we're going to go ahead and try to do that with my data back in Excel. All right, so first thing I'll do is I'll scroll down here. Let's go down a bit, and we're going to make the covariance and the standard deviations using those formulas. So I'm going to go ahead, let's go ahead and put that here. Yeah, let's got space here, covariance. Oops, covariance. And then we're going to say standard deviation. I'll just call it standard deviation of x, standard deviation of y. So actually I could just call this covariance like that. Okay. So what I'm going to do here is use a formula, and I'm going to make a sum of all the elements that are right in here, the x bar times the y bar. And in my observation, I believe I have 30 students, so I'm going to take that and divide it by 30. And that for x. So we're going to say okay, now we're going to do our standard deviation for x values here. So that's going to be my English test scores in this particular data set. So this is going to equal square root. Start with square root, and then you put sum, and then we're going to do the x minus x bar squared. This is why we created this column. Alright, and we're going to close this off, and then we're going to divide this by the number of elements I have, which is 30. And then we're going to close that off. And that's going to be the standard deviation for my x values. We're also going to go ahead and do standard deviation for the y values. So this is going to equal, again, square root. Go just like that. Now you're going to type in sum. Now we're going to do the y minus y bar all squared values here. This is why we created this one, to find the standard deviation of my math test scores. I'm going to close this, divide this by the number of scores, which is 30, and then close that. And that will be my standard deviation for this. Now, what I'm going after, what I'm trying to find, is Pearson's product moment correlation coefficient, which is the R value. Okay, so if you're doing all this by hand, this is how it's done. So I'm going to say, just go ahead and say R value, or R right here. And this is going to equal, it's going to end up equaling here, this stuff here. It's going to be it's going to be this value divided by the product of these two values is really what it is. So I'm going to go ahead and say that value. Let's go ahead and say this is this divided by this times this. And that is my R value, which is now for me 0.65 thereabouts. But since it's greater than 0.5, this is a moderate correlation, positive correlation. And because it's greater than 0.5, I can go ahead and create a linear regression equation from that, if I so desire, and that would be acceptable. So now that I have this, what I can do from here is I can go ahead and add another page here. Actually, what I'll do, I like to copy this data over and over again so I don't have to keep going back to previous pages. But I'm going to just copy this, Control C, copy, and create a new sheet in the document, paste that down. And what I'm going to do is do a scatter plot and put a trend line in it. Okay. And what I'm going to do for this is I'm going to select, well, let's actually do it this way. Let's do insert scatter plot. And then I'm going to right click this chart it's given me and do select data. I'm going to go to add and call the series name. This is going to basically be English scores versus math scores. This is basically the title, what you got here. I'm going to select the X values, that will be my English scores. And then it wants the Y values. So my Y values will be my math scores. It really doesn't make a lot of difference which one you choose if you're doing something like this. And then I hit OK. And then we're going to hit OK with that. And what I end up getting is a scatter plot, pretty much, of my data here. And as you can see, there was a moderate positive trend here, correlation. I'll go ahead and delete these grid lines. I don't want them. Okay. And alrighty. What you can do actually is you can go ahead and click the add chart elements and select trend line. This will be your linear regression trend line. right here. So if I go ahead and select this trend line, it'll give me the format trend line menu right here. And what I want to do, actually, make sure it's linear. As you can see, it already is. And I'm going to come down here and display the equation on the chart, and go ahead and do the R value, I guess we could do. And this is basically the linear regression equation you would have created by hand. And when you create it by hand, it should look very similar, if not exactly the same as this. I also want to test the accuracy of my R value from the previous process I did. So here's my R value, the R square value. They give you the R square value here, which is called the variance. So if I take this R square value, I can redo the R value just to make sure it's correct by taking the square roots. It says this is equal to the square root of this particular decimal they've given me, which is 0.4327. So I want to see if my value is the same as Excel's. So if I hit enter, I see that the R value is this. It's 0.657. I'm going to go back and look at my work right here from the previous page, and I said the R value is 0.657. It's exactly the same, so it's accurate here. So what I'm going to end up doing is copying basically all of this data into a table and putting it in my IA, and of course making the labels nicer. Word is better for that than Excel. But I hope that helps, and what we've done here is a linear regression line. You will have to show the actual calculation of this equation in your paper, but that's pretty trivial once you have the equation. So I hope that helps, and good luck to you guys. All right, bye.